Hello everyone. Today we'll be learning how to plot a curve of best fit using this question as an example. The question says, a student varies the resistance of the variable resistor. The table shows the power of the loudspeaker for different resistance values of the variable resistor. So it's fairly obvious that when I change the resistance of the variable resistor, because that is something you change manually, the power of the loudspeaker varies. So that makes power my dependent variable and the resistance independent variable. So that piece of information is useful in this regard, that we generally, not always, and there is no such rule, but we generally plot the dependent variable on the y-axis and the independent variable on the x-axis. The next thing what you should be concerned with is the scaling. So the power starts from 0 and starts from 84 after 0 and then goes all the way up to 113. So I'm saying these values because I see a lot of times students struggling with very small numbers like this. So 0 is same thing as 0, but if you can turn this into 100 times 10 to the power minus 3. So 100 times 10 to the power minus 3 is the same as 0.100. Same goes with this one, as in 113 times 10 to the power minus 3. And this will be 108 times 10 to the power minus 3. And this will be 100 times 10 to the power minus 3. This becomes 92 times 10 to the power minus 3. And this would be 84 times 10 to the power minus 3. Now it's much easier to deal with these values, but you might be wondering, but the question did not say 100 or 84. The question says 0.084. So you can incorporate that in your labeling of the axis. For example, if you write the power values, all the power values are times 10 to the power minus 3. So once you have done this, then you can directly deal with these values and not the smaller ones, because it comes down to the same value. And this is still going to be in the same unit as in watt. And for the resistance, what do I choose to be the scaling? So you see the smallest value is 0, and the highest value is 15. So if you do a scaling like this, as in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You cannot plot all of the plotting points over here. So you have to change the scaling. What you can do is you take 1, 2, 3, 4 blocks to be 5, then another 4, 10, and 1, 2, 3, 1, 2, 3, and 4, 15. So in that way, you can cover all of the plotting points over here. So this is my resistance. And the resistance is in ohm. And this value becomes 2.5. This is 5. This is 7.5. This is 10. This is 12.5. And finally this would be 15. And now let's move on to the power values. The power value has a huge range. It starts from 0 and goes all the way up to 113. So if you take each block to be 10, this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, and 120. So this is 10, 20, 30, 10, and finally 120. So scaling is very important along with labeling the axis. Okay, after you're done with scaling and labeling your axis, next up you'll have to plot the plotting points. So 0 corresponds to 0. So 0, 0 is a plotting point here. 2.5 corresponds to 100. So 2.5 corresponds to 100. You can put a cross here. 5 corresponds to 113. 5 corresponds to, this is 100, 110. Okay, so how do you deal with the small squares? How do you know the small square represents how much? So you can start from the bottom. So 1, 2, 3, 4, 5. 5 squares represents 10. So 1 square represents 10 by 5. That is 2. So this is 5. This is 110. 112, 114. So 113 must be somewhere between, not somewhere, exactly between 112 and 14. So you put a cross over here. 7.5 corresponds to 108. 7.5. This is 100, 102, 4, 6, 8. This is 108. Then 10 corresponds to 100 again. 10 gives you 100. 12.5, 92. 12.5, this is 90. 92, exactly 1 square. And finally 15 corresponds to 84. So 15 corresponds to 80, 82, 84 over here. Okay, now the moment of truth. How do you draw a curve of best fit? First, let's figure out what does the curve of best fit even mean. Best fit means it can be a line or a curve. For this specific question, they're asking for a curve. So for a best fit, always remember there has to be equal number of points above and below the line. It's not possible always to make your line go through all of the points, and when there are scatter points, you have to ensure that there are equal number of points above and below. So if you look at this curve, you'll see these two fall on the graph, and then the graph peaks somewhere over here, and there is no way you can make the graph go through all of the plotting points. So what do? You have to make one smooth curve, and you have to do it in 2 sections actually. It's not possible to do it at one go. So turn your paper like this and do it section wise. This part is pretty easy. You have to figure out this part first. So over here, what you can do is the peak should be somewhere over here. Yes, this is the much better one. So this is the first segment of your graph, and then you draw the line. And after this, you have to bring it all the way down to 0. Now you have your proper curve of best fit. And once you're done with this, you can thicken this line a little bit. And with your new eraser, of course, you can rub off the extra pieces, extra lines that are still evident over here. And once you have done that, you'll see these 2 points go perfectly. The line goes through these 2 points, and 1, 2. 2 plotting points are below the graph, and 2 plotting points are above the graph. So that's how you plot a graph of best fit. Thanks for watching.